Now let's set up dynamic security for the account dimension. Again, we're going to use our dynamic security database, and we're going to set up a bridge table for account user combinations. So here we have 3 different accounts that we're assigning to user ID number 2, and that happens to be John again. So let's go back to our development environment. We need to add into our data source view the new table. Pointing to dynamic security and bringing in the account user bridge table. And we need to define the relationships. So we'll go from the account user to the users table. And then we need the account. So we'll go from account key to the account key in the account table. So now we have our relationships defined correctly in the data source view. Then we'll go to the cube. We already have our users dimension from the previous demonstration. We'll add in a new measure based on the count of rows in our account user table. And in the dimension usage, we'll have a new account user linking in our account to secure account and users. And it happened to detect for geography as well. We're just going to eliminate this relationship. And now we're ready for a new role. Now before we set up that new role, remember that we have John in the geography role as well. And in the Analysis Services Fundamentals course, in the security topic, I explained that when you have role security set for different dimensions, you need to make sure that you block the user from the opposite dimension in each role. In other words, when we have a user that's going to be in the geography role and the account role, we need to make sure that all of the accounts are inaccessible to the user from the geography role. Otherwise, Analysis Services security is additive. So when the geography role allows the user to see all accounts, even though the accounts role is going to exclude some accounts, the ability to see all the accounts because of the geography role is going to win. So we need to deselect all of our members here in the geography role. We'll save that. And then we will add in a new role for account. And we'll add John again. And we need to, in this role, make sure that he's got read access to the cube. Then we go to the dimension security. Remember about the opposite dimension. So with geography, we're going to make sure that we set the state province to where we deselect all members here. And then we can add in our account security on the accounts dimension. Notice that the key attribute account is not listed here. We only have access to the individual non-key attributes or the parent-child hierarchy, but not the key attribute itself. So let's go ahead and create a set. And here we're using similar logic as we used with the geography dimension, where we have the account members or members of the accounts hierarchy intersecting with individual users, and where those intersections occur, the user is going to be able to see those accounts. So let's deploy our changes. And then we can go to the cube and browse it after we impersonate John. And here we'll use finance data for accounts. And here we have multiple accounts. Gross margin, operating expenses, net sales, total cost of sales, and we see many more accounts than we should. Those accounts that we loaded into the bridge table were specifically the trade sales and the standard cost of sales and units for our statistical accounts, which don't show up here because we need to remove the non-empty switch in this browser. But nonetheless, we're seeing many more accounts than we should. And the reason is because with the parent-child hierarchy, the addition of the trade sales, for example, as well as the standard cost of sales, meant that the parents, such as net sales and total cost of sales, roll up into gross margin and all the way up to net income. This parent inherits what the children members could see. And this is a slightly different behavior than we get in a standard hierarchy. So what happens is this set returns members including the net income account. And if we can see the net income account, we can also see all of the children, and we can see all of the descendants. And so that's a problem. So in a parent-child hierarchy situation, we actually need to modify this set definition. So here we have a slightly different expression. We continue with this idea of using the non-empty function to find the intersection of accounts and users. But this time what we're doing is we're using the account key attribute. Now the account key attribute is not listed here, remember, but we're going to get a set of members where we have intersections because the key values are the same whether we're using the parent-child hierarchy or the account key attribute. So the set that we're going to get will be based on the account key attribute, but we need to translate that into the account's parent-child hierarchy. And the way that we do that is with the generate function, which is like a for each loop that iterates through this set of members that the non-empty function returns, and it looks at each one individually, and it uses then this link member function that says, okay, for each one of those that's found, that's what this account current member is doing. It's saying for each one of those members that gets returned in this first set, use the link member function to find the corresponding accounts parent-child hierarchy member so that that gets returned instead of the account key attribute member. And so we get to the place we need to be, but here we're only going to get a set of the explicit members that are found in our account table and not get a member of other levels because of the parent-child hierarchy, which is what the non-empty function did previously. And so we can see the effect if we deploy this and test the results. We'll go back to the Cube browser. And now notice that we're only seeing a specific set of parents here. And as we drill down, we can see trade sales and standard cost of sales, but we don't see any of the other accounts. Now there was a third account that we could see in the table that's not showing here, and that's simply because the browser hides the statistical accounts for us. But here we have the units, and then a custom roll-up member that is associated with units. The average unit price is calculated here as well. So we can use dynamic security with our parent-child hierarchy, but we need to modify the expression so that we return only the members that are explicitly set in the table and not other members that are going to return for other levels within the parent-child hierarchy.